Good morning, dear students. Beta, today we will discuss RDA worksheet 58 from your chapter Light. And in continuation of that, today we will discuss about spherical lens. In our previous worksheet, we have already studied about the spherical mirrors and their mirror formula. Okay. What are spherical lens? A transparent medium bound by the two surfaces of which one or both surfaces are curved are called as spherical lens. See, these are curved surfaces. Okay, these are called as lens. What about there are two type of lens: convex lens and concave lens. Now, what is the difference between these two? One lens is thin from the corners, thick from the center, and converging lens, and another is thick from the corners, thin at the center, and diverging. What is this converging? Converging means all the ray of light focus at a point. That lens is called as converging lens, and diverging lens when all the ray of light spreads out after going through this lens. These are the rules of the image formation by the concave or convex lens. Then first is when this ray is passing over the over to the polar axis, it moves, it bends towards the focus to the other point. The same is the case of concave lens also. See, this ray of light bend towards this and after coming down to the focus. Next, we have the ray of light passing through the optical center is of either lens will encourage without any deviation. If it move from the optical center, then it bend return it bend back to the same optical center. Same is the case with this also. This is we have, if this is moving with optical center, it is coming back to the optical center. Next we have lens formula. In lens formula we have this 1 upon f is equal to 1 upon u v minus 1 upon u. In mirror formula we have 1 upon v plus 1 upon u, but in case of lens formula we have 1 upon v minus 1 upon u. And see, the degree of the convergence or divergence of the light ray achieved by the lens is expressed in terms of its power. Now, what is power? Power is the degree of divergence or converging of a lens. Power can be written like this: 1 upon p is equal to 1 upon f is called as power. Okay, and it should be measured in diopter. Now coming to this side, we have ray diagrams made with the help of these rules. First of all, we have the light rays coming from the infinity. After converging at focus, they form point size, highly diminished point size image, but real and inverted. And this image should be at focus. And when the object is beyond 2f, then the rays are coming. One ray is coming from which is parallel to principal axis, bent towards the focus. Another ray of light is passing through the optical center, coming back to the optical center, and where these two lines met, the image formation is taking place. This is diminished, real, and inverted. Third case may we have the object at 2f, then image is formed at 2f. It is of same size and real and inverted. And when this object is between 2f and f, then the image formed at beyond 2f, and it is highly enlarged, real and inverted. And at f, when object is at f, the image formation is taking place at infinity. And lastly, we have an object is between F and O. Okay, so this image is formed in front of lens. This image is formed in front of lens and enlarge. See this, enlarge, virtual and erect. This is erect. Okay. Then we have the ray diagram for the concave lens also. Same, these line rays are coming from the infinity and after uh, getting refracted by the lens, they meet at the focus and form the image. Okay, again it is highly diminished point size, virtual and erect. Another diagram we have when our light is passes through this and move towards, bend towards like this, and this second ray passes through the optical center, coming back to the optical center where these 2 points are meet, the image formation is taking place, and this is again virtual and erect. Okay, let's do practice exercise with this. We have, see, whatever we have given, with a 5 cm tall object is placed at a perpendicular to principal axis of convex lens of focal length 30 and an object is 30 centimeter away from the lens. This is the height. This is the height of object, that is 5 centimeter. Whatever is given, we must write 30 centimeter. We have to find out V, then F is equal to 10 centimeter, right? Now applying the formula by putting the value of all these, minus is equal to 1 upon V. 1 upon V you have to find out 1 upon U. 1 upon U we have minus 30. So if this 10 is 30 is coming to this side, then this minus changes into plus, but this remains the same. Okay, and if we then we take, if we take the LCM of this, so minus 30 would be the LCM, and if we divided it with the 10, then remain minus 2. That is, let me write it again for you, otherwise see 1 upon V is minus 1 upon U is equal to 1 upon F. 1 upon V minus 1 upon 30 is equal to 1 upon 10. If you find out the value of 1 upon V, then we have, this is the sign of equality, 1 upon 10 plus 1 upon minus 30. If you take the LCM here, it will become 3, and this plus minus minus 30 30 1 1, that is 2 by 30, that is 1.5 centimeter. Sorry, 1.5 ni 15 centimeter, because this is 30 na, 15, sorry, this is 15 centimeter. 15 centimeter. So now we have m is equal to v by u, that is 15 upon minus 30. Then we have m is equal to 1 by 2 minus 1 by 2, and m is also equal to v upon u, that is hi upon ho, half minus half is equal to hi upon 5. Then if we made a cross multiply, then h is equal to 2.5, and this minus sign show this is inverted image. Okay, in this position, its positions between f and 2f, right? Size is minus 2.5. It's real and inverted. Let's do next question. We have a thin converging lens form a real magnified image, virtual magnified image. Okay, first you have to draw real magnified image. For that you have to draw, see, real magnified image. Then you have to draw this diagram in the second question, and write virtual magnified. Then you have to draw this virtual magnified, means you have to draw these two diagrams, and yes, you have to draw these two diagrams with labels and all. Okay, so this is all about your today's worksheet. I hope you understand it. So thank you, students.